Today we're going to look at something called complex fractions. Complex fractions are fractions that have individual fractions on the top and individual fractions on the bottom. So it looks like a fraction on top of a fraction. And our job with complex fractions is to reduce these fractions as much as possible so that we get just one fraction. If we look at our introductory problem here, I have 1/2 plus 3/5 divided by or over 3/4 minus 1/8. So our goal here is to simplify the top, simplify the bottom, and then we'll treat this as a division problem. So once I get one fraction over one fraction, I can treat it like fraction division. And we know that when I divide fractions, I can actually rewrite that as multiplication. And once we have a multiplication set up, it should be pretty easy for us to be able to reduce. So if we take a look at our intro problem, in order to add and subtract fractions, I have to have a common denominator. My common denominator for the top portion here would be 10. So in order to get each of these to be something over 10, I have to multiply the first term by 5 on top and on bottom, and the second term by 2 on top and on bottom. So that would give me 5 over 10 plus 6 over 10. In the denominator of my complex fraction, my big fraction here, I have 3/4 minus 1/8. So my common denominator here, I can actually just use 8. So this first guy I'm going to rewrite as something over 8, and the second term is already something over 8, so this guy stays exactly the same. And then my first term, I had to multiply the bottom by 2 to get a denominator of 8, so I also have to multiply the top by 2. So I have 6 over 8 minus 1 over 8. Now I'm going to go ahead and do my addition here. That would give me 11 over 10 on top and 5 over 8 on bottom. And now I have just one fraction on top of just one fraction. So what I'm going to do here is rewrite this as division. That's another way to think about fractions. I'm saying divide this thing by this thing. We know how to divide fractions. I know that if I want to divide fractions, I have to copy, change, flip. So copy that first term, change the sign to multiplication, and then flip that second fraction. So now I can actually go ahead and finish simplifying this. 10 and 8 have a common factor of 2, so I can reduce the 10 to 5 and the 8 to 4, and then I get 44 over 25. We're going to do the same thing in our notes today, but with rational expressions instead of only fractions. So if we take a look at our first example, we have x plus 5 plus 4 over 8 plus 1 over x. There are two methods that we'll use to approach these problems. The first is very similar to what we did with our intro problem. Simplify the top, simplify the bottom by getting common denominators so I can actually do my addition or subtraction, and then flip and multiply. So that's what we'll look at for method 1. So for method 1, if I want to get a common denominator for the top and then a common denominator for the bottom, I need to look at the denominators for these individual parts. So if I just look at the top part here, I have x over 5 and 4 over 1. My common denominator here would be 5, so I could rewrite this as x over 5 plus, to get this to be over 5, I have to multiply the top and the bottom by 5. So that would be 20 over 5. For the bottom portion of my fraction, I've got 8 over 1 plus 1 over x. My common denominator here would be x. So I have to multiply the top and the bottom by x for that first term. That would give me 8x over x plus 1 over x. This second term is going to stay the same since it already had our common denominator. Now I'm going to go ahead and do my addition. On the top, that would give me x plus 20 over 5. On the bottom, I would have 8x plus 1 over x. Now what I have here is a fraction divided by a fraction. So I can rewrite that as multiplication. I have to flip this second fraction to be x over 8x plus 1. And then I would look to see, is there anything I can reduce? In this case, I don't have any common factors between the top and the bottom, so I just need to multiply straight across the top and straight across the bottom. So I have x times x plus 20 over 5 times 8x plus 1. You can leave your answers in this factored form, or you can distribute if you'd prefer. If I distribute, my numerator would be x squared plus 20x, and my denominator would be 40x plus 5. Either version is acceptable.